Let's talk about partial fractions with an irreducible quadratic factor in the denominator. The example that we'll use is this one, and notice that everything is as factored as it can possibly be already. Even though we've got a square here, x squared plus 3 is prime. Now, just like before, we want to take each of these factors and make them the denominator of their own fraction. The place that's going to be different is now with x squared plus 3 being quadratic, we'll need a linear numerator above it. Our numerator should be 1 degree lower than what our denominator is when we do partial fractions. So this x squared needs a linear exponent of 1 as the numerator. Now, our other factor from the original denominator, x minus 1, since it's linear, we can have a constant value of c above it. Now, just as we've done before, we want to multiply every fraction by the lowest common multiple to get rid of the fractions. Just as we've seen before, the lowest common multiple is the original denominator that we started off with. So everybody here, all three fractions on both sides of this equation, will be multiplied by x squared plus 3 times x minus 1. When I do that on the left-hand side, obviously everything is going to cancel out, and it's going to leave me just the numerator of the fraction. So the left-hand side, once we've multiplied by our lowest common multiple, will be just 4x squared minus 3x plus 7. Now on the right-hand side, as we multiply through by that lowest common multiple, x squared plus 3 times x minus 1, there are going to be some things that are going to cancel out for us. So as we multiply the first fraction on the right-hand side, this fraction is being multiplied by our lowest common multiple. Notice that the x squared plus 3's match up and will cancel out. I've got them highlighted in green so that you can see that they match. That leaves me an x minus 1 that I should multiply with ax plus b. On the back, when we multiply by our common multiple, notice that the x minus 1's match up. They're highlighted in blue for you to see that they match. When they cancel out, that will leave me c times x squared plus 3 to multiply. Well, as we do our multiplication, the first part that was left over, x minus 1 times ax plus b, this is binomial times binomial and should be fold. X times ax is ax squared. On the outside, x times b is bx. On the inside, minus 1 times ax is minus ax. And then the last one's negative 1 times b made negative b. Let's distribute the c on the back. C times x squared made cx squared, and c times 3 makes 3c. So our product is here once we've multiplied everything out, multiplying by our lowest common multiple. Now, I want to rearrange things so that the square terms are together. You see that they're in red. I want the x terms to be together, but I would prefer that they're in alphabetical order. And then I want the constant values to be together as well. They're the ones that are in green here and don't have an x tied to them. I want them to be in alphabetical order as well. The commutative property tells us we can move things around however we want to. So I'm going to reorder it with the x squares together, with the x's together but in alphabetical order, and with the constant values together and in alphabetical order. When we do that, and bringing down the original numerator on the left-hand side, we'll end up with this line. Notice that my squares are side by side. My x's are now alphabetical and side by side. And the things that didn't have an x tied to them, they're together and side by side in alphabetical order. Let's now take each of these parts and equate the coefficients that we've been given. We know that the two sides should equal each other, so 4x squared has to come from adding together ax squared and cx squared. Equating those coefficients means that a plus c must equal 4, and that gives us the first of 3 equations that we'll have. A plus c, the coefficients of the x squares, have to add up to be 4, the coefficient of the x squared on the left side. I've highlighted this equation because we're going to need it a little bit later in the problem. Let's see if we can equate the coefficients for the x's. These are the things that are in blue. -3 needs to be the result when you add up -a plus b. So -a plus b should equal -3, gives us our second equation. And same thing with the constant values. 7 should be the result of putting together -b plus 3c. -b plus 3c is equal to 7 is our final equation. Now, look at these bottom 2 rows. Notice that the b's are opposites of each other. If we add these 2 rows together, we can get a new row that eliminates b as a variable. So let's see if we can do that. Adding these 2 rows, there's nothing to add to the -a, so let's bring it down. The b's canceled out. That was why we were adding these things in the first place. There's nothing to add to the 3c, so let's bring it down. And then -3 plus 7 gives me 4 on the bottom. Now, this one is also highlighted as well. What I want to do now is to take the row that we've just created and highlighted, and I want to put it together with the other highlighted row and do a system of equations with those. Notice that both of those highlighted rows only have a and c as variables, so it'll be easy for us to do a system of equations with them. Let's take each of these highlighted rows and move them over here. The first one, a plus c is equal to 4, and the second, -a plus 3c is equal to 4. Those are our 2 highlighted equations. Notice that the a's are already opposites of each other. So we can add these 2 rows together and eliminate the a's. When I do that, c plus 3c gives me 4c. Adding together the 4's, 4 plus 4 makes 8. Now 4c equals 8 is easy for us to solve. Dividing both sides by 4 looks like c is going to be 2. If c is 2, I can figure out the rest of these things pretty easily. When c is 2, we can come right back to this equation, put 2 in the place of this c. That would give me a plus 2 equals 4. Subtracting 2 from both sides, I would find that a is 2. So if a is 2 and c is 2, we can figure out b pretty easily now as well. Remember the line over here that said -a plus b equals -3? Let's use it, -a plus b equals -3, and see if we can figure out what b is going to be. Our a is 2, so let's take 2 and put it in the place of this a. That gives me -2 plus b equals -3. Let's add 2 to both sides. Adding 2 tells me that b is -1. So now I know my values for a, b, and c. But now our problem was that we needed to write this as a fraction, the sum of 2 fractions. Remember that x squared plus 3, our first denominator, had ax plus b over the top of it. So if we make this ax plus b, a was 2, here is our 2, b is -1, so ax plus b ends up 2x minus 1. C was the value that we had over x minus 1. If c is 2, put 2 over x minus 1, and now we have decomposed our fractions. Let's try another example. For this one, notice that we're only being asked to find A, B, and C, and that the partial fraction decomposition has already been set up for us. Everything is as factored as it can be. You need x squared plus 4 as one denominator and x plus 1 as another denominator, since each of the factors become their own denominators. Now, this one was quadratic, a degree of 2, so it needs a linear numerator, ax plus b. This denominator is linear, so it can have a constant value for its numerator. Now, that is our partial fraction decomposition set up for us. Let's multiply everything by the lowest common multiple to get rid of the fractions. What is the lowest common multiple always going to be? The denominator of the original fraction before the decomposition is the lowest common multiple. So everything is going to be multiplied by x squared plus 4 times x plus 1. When we do that on the left-hand side, I'm left with just the numerator, x squared minus x minus 7. That's all that's left on the left-hand side. On the right-hand side, we're going to have some things that will cancel out. When we multiply both fractions by our lowest common multiple, x squared plus 4 times x plus 1, for the first fraction, the x squared plus 4's match up. I've got them highlighted, and it leaves us ax plus b to be multiplied by x plus 1. For the second fraction, the x plus 1's match up with each other and cancel out. So I've got c that is to be multiplied with x squared plus 4. Now, once we get ready to do our multiplication, remember the front part is binomial times binomial. So ax times x makes ax squared. Ax times 1 made ax. B times x makes bx. And then b times 1, the last one's made plus b. Let's distribute on the back. C times x squared gives me cx squared. C times 4 gives me 4c. Now, I again want to reorder things so that the like terms are side by side. My squares in red can be put side by just moving this cx squared to the front. I've already got the x's together and in alphabetical order, ax plus bx. Let's take this b and move it back here with the 4c, and let's put those in alphabetical order as well. I'm going to bring down the original numerator. Here was the original numerator. It's the left side of our equation, and I've put 1's in as coefficients to help us as we start to equate in just a second. On the right-hand side, the like terms are now side by side with each other. Now we can equate the coefficients and put together some equations to help us solve. Now, I'm going to choose this time to equate the constant values first. The order that we write our equations in makes no difference, but that's the one that I'm going to want to keep separate to use later in our problem. So let's take the constant value -7 and set it equal to b plus 4c. So -7 is the same as b plus 4c. The things that did not have x's attached over here should equal the thing that doesn't have an x attached over there. Now let's equate the coefficients for our x squares. 1, the coefficient of the x squared on the left, needs to be the result of adding together ax squared plus cx squared. So a plus c should equal 1. 1 is equal to a plus c. And then for our x's, -1 is the coefficient of the x. That's going to come as the result of adding together this a plus b. So -1 is the result of a plus b. Now, I've stretched these things out a little bit so that hopefully we can see a little more easily how our systems of equations are going to put together. Let's take these bottom two rows and see if we can put those things together to eliminate one of the variables. Now, the top equation, I'm going to leave it just as it is. But the bottom equation, so that I can get opposite coefficients on the a's, let's multiply here everybody on this equation by -1. When I do that, the effect is to change every single sign. So instead of a -1, we'll have a +1. Instead of a positive a, we'll have a -a. And instead of a positive b, we'll have a -b. Now, let's combine these two rows. 1 plus 1 made 2. The a's are going to add out. I've got a -b that doesn't combine with anybody, and I can bring it down. And I've got a positive c that won't combine with anybody, and I can bring it down as well. So this gives me a new equation that only has b's and c's as part of it. Now, the two equations that are highlighted, the one that we got originally from our constant values and the one that we have created with our system of equations, let's do a system of equations between those things. So I'm going to take this row and bring it right here. I'll take this new row and bring it right here. Notice that the b's are already opposites of each other, so I can do elimination immediately on this particular problem. Adding together -7 and 2 gives me -5. The b's added out since they were opposites, and 4c plus c gives me 5c. Now, this is an easy equation for us to solve. If we divide both sides by 5, we'll find that c is -1. Once you know that c is -1, it's going to be easy for us to get the other variables. Coming right back to the equation here, where we had equated our x squared terms, we can now figure out what a is. If I know that c is -1, I'll put -1 in for c right here. When I do that, the equation 1 equals a plus c becomes 1 equals a minus 1. If I add this 1 to both sides, adding 1 gives me 2, so a is equal to 2. At this point, I know that a is 2. I know that c is -1. I can pretty easily figure out b once I know those things. The equation that is here, if you take 2 and put it in for a, you'll be able to get what your b value is. So if I take 2 and put it in for that a, then if I subtract 2 from both sides, looks like b is going to be -3. We were asked on this problem to find a, b, and c. b is -3, a was 2, and c was -1. So we're done on this particular problem. If we had been asked to write the fractions, we would have taken the 2 that we have here and put it in for this a. We would have taken the -3 that we found for b and put it in for this b. So this would have said 2x minus 3. We would have taken -1 and put it in for this c, and probably we would have taken the negative sign and moved it down here in front. So now anytime that we are trying to decompose into partial fractions something that has an irreducible quadratic factor, remember, each of the factors in the original denominator must have their own fraction that they become the denominator for. The one that has the irreducible quadratic should have a linear numerator 1 degree lower, while anything that is a linear denominator can have a constant value for its numerator. Once we have set up our partial fraction decomposition, multiply through by the lowest common multiple to eliminate the fractions, equate the coefficients, and then work the resulting system of equations. If you're asked to express your answer as a fraction, be sure to go back and write each thing over the appropriate denominator.